Welcome to my YouTube channel. I am Malo Patel. I am from IIST, and today I am going to show you a project on computer vision which is based on image dehazing. And I have made two models here, guided filter model and the fast Fourier model. The guided filter model is based on atmospheric scattering, which is based on this equation, this one. I'm going to show you the working of the code. So this is the code here. We use different Python libraries. Here, this is a function to get the dark channel. Here, this function we are using to estimate the atmospheric light, which can be shown here. The brightest 0.1% of the pixel in the dark channel is corresponding to the haze. Our main aim is to find the atmospheric light A and the transmission map T, through which we can reconstruct the dehazed image J of x. So here we get the A from this function. It takes into account 0.01% of the pixel. Here we are defining to it the transmission map where we use the weight omega, which we took it as 0.95. And here this function we are using it to refine the transmission map using a filter, which is the guided filter here. It is basically used to optimize the transmission map obtained. Here we are recovering the scene gradients g of x using the formula, this one, where I of x is the easy image. We are finding t of x and a to reconstruct j. Here I have this function is used for computing the evaluation matrix, peak signal to noise ratio, structure similarity index, mean squared error. Here I have defined everything. Here we get the dark channel, here we get the atmospheric light. From this we get the transmission map, from this refined transmission map. And finally the dehazed image from the refined transmission map and the atmospheric light. We want to save the dehazed image to some directory. Here I have chosen one, and here to show the plots. Here you can give the image path to any of the easy image, which I'm going to show you live. So I'm going to search for some easy images. I'm going to pick anyone at random. Suppose take this one, save this image. And see it is saved here. Then we just go to see the image path. And then I would like to save the dehazed image. It is the ground truth path. The same used to for save of so save. This here is running. Round to the image loaded successfully. So here I'm showing for the atmospheric scattering model. After that I will show you for the fast Fourier transform model. So here you can see we got the images, the hazy one which was input. Here we got the refined transmission map. Here's the dehazed image, and here you can see we got the performance matrix as well. Matrix. So in this way, this was one model. Now we come to another model, fast Fourier transform model. And this we defined C0 and C1 as weighted constants is used in this equation, which is 50 based optimized model. Here you can find the for estimating the transmission map, we use two weighted constants, C1 and C2. So that we define here. Here this function is used to estimate area wave, but using another approach, not using the 0.1% of maximum pixels. Here we are using this function to estimate A. See here we are using C1 and C0. And the transmission map here we are using a burst filter instead of guided filters, which is an 8-directional filter. GB scales the image and circular convolution filter, calculating the transmission map. And beta, we use a penalty parameter. We refine the transmission map using augmented Lagrangian method. So that is what is shown here. And we are reconstructing J of x using a weight epsilon, which can be chosen arbitrarily. This spread function is, we compute the fast Fourier transform of this, it creates the optical transfer function. This is shown, it's adapted from the MATLAB function of PSF to UTF. And we reconstruct it. Then zero pad shaping the image here using this function. This after estimating air light A transmission map and applying the filters, here we can get the transmission map of the hazed image and corrected haze image. Then this function is used to calculate the performance matrix as shown for the previous model as well. So this is the main function, main body of the code, the model. So let us use the same image path and try to run it. So the hazy image path is this. We want to save a dehazed image here. So, so it's running here. So you can see this is the transmission map, and this is the obtained dehazed image. So this is from the fast Fourier method, and here we get the performance matrix. So this was a demo of comparing two models, one using the atmospheric model, one using the fast Fourier one, which is for image dehazing. So thank you for watching the video. Please do like and subscribe the video. YouTube channel.